All right, so I'm going to go to this website right here. What we're going to be doing is trying to figure out the average daily phone screen time for all AP Statistics students. We're going to consider our class of students as a random sample for all AP Stats students. So I'm going to go to statsmedic.com/applets. Click on it right here. All right, so what kind of a variable do we have? Quantitative or categorical? Quantitative. How many groups did we look at? Just one group, just you guys, right? I collected data from this class. I collected it from 5th period too, but we're just going to be analyzing the data here. So I'm going to go to the one that says one quantitative variable, single group. All right, and then variable name. This would be daily phone screen time. And we're going to enter this data in. So 647, 145, 423, 312, 595, 698, 272, 335, 327, 100, 290, 512, and 489. And then we're going to begin analysis. All right. Here we go. We've got a dot plot. What do you guys notice about that dot plot? Kind of spread out, right? Does it look like it has any like really strong skew or any outliers, anything jump out to you that's weird? Not really. I think it looks pretty evenly distributed. What is our N? N is 13. What is our X bar? Where would we go look for that? What does X bar mean? It means sample mean. So what is our sample mean? Can you guys see it from back there? Yep, 395.769. All right, so on your paper, I need you guys writing these things down. And I'm going to have to ask you because when I go back to the paper, I won't be able to look at this. So our N is 13, mean is 395.769. And then it also wants us to find S. What does S mean? Sample standard deviation. So what would that be? 184.708. Write those three numbers down up at the top of your page. So everybody got them down? Which one do you need? S. You're going to be going with standard deviation because S is the sample standard deviation and we've only entered our data. I can read it to you. It's 184.708. Everybody good and have those numbers written down? All right, because I'm literally only going to be able to remember one of them when I flip back. Number N was 13, right? All right, and then X bar was 395, you said 0.765? 769. And what was S? Beautiful. All right. We are going to walk through the 4 C's using this data. Together, we're going to do the choose and check. And then I'm going to set you guys loose on your own to do the calculate and conclude. And then we'll come back together and check your work against mine. All right? So let's start with choosing our procedure. When we did this for proportions, When we did confidence intervals for proportions, we said it was a one sample Z interval for P. Is it still a one sample? Yes. Is it still a Z interval? No, now it is a T interval. So a one sample T interval. Are we still doing this for P? Now it's for mu. It's for mu. One sample T interval for mu. They told us the confidence level they want us to use. What confidence level are we using? 95%. One of the things I noticed when I was grading the tests was some people were just writing down parameter and then defining it, but they didn't have. I do not know. I'm sorry. I wish I did.
Get the star.
Absolutely, I can. You have to state what symbol it is you are using to represent your parameter. So what are we using to represent the parameter this time? Mu. Our parameter is called mu. So when we define this parameter, it would be mu equals what? Absolutely correct. The true mean screen time for all AP Stat students. And then we get to the check. What are the things that we need to check? Random, 10%, and large sample, which we're checking large sample to check for what? We're checking for normality there. Do we get random? Yeah. Why? Yep. It says up here, consider our class of students as a random sample of all AP Stat students. So we're going to go ahead and treat that as a gimme. We're assuming that you guys are pretty average, pretty normal as far as screen time goes for all AP Stat students. All right. Let me pop that up on the screen here. And then we need to check our 10%. What would that look like? How would I check that? 13 is less than or equal to 10% of all AP Statistics students. All right. Normal, large sample. How many different ways do we have of satisfying this condition? We've got 3 different ways of satisfying this condition. What's the one we always check for first? If the population is approximately normal. Do we know that? I have no idea what the population distribution for this would look like. So we can't make that assumption. What's the second way that we go look for? Central limit theorem. And central limit theorem says I need at least 30. Do I have at least 30? No. Okay, so I can't use central limit theorem. So both of those got thrown out. What's the other option? What's our third option if neither of those will work? Yes, if the graph of the sample data shows no strong skews or outliers. So let me go back here. I took a picture of the graph, and I'm going to throw it up on the screen. Ooh, I need to make it a little bit smaller. So that's what the graph of the sample data looks like. Does it show strong skews or outliers? No. You would need to get like a quick sketch of this drawn next to this condition. As we say, the dot plot shows no strong skews or outliers. So go ahead and do that on your notes page. It doesn't have to be perfect, but you need the general shape of what this graph looks like. And then we actually have to write down next to that what we are observing on that dot plot. Dot plot shows no strong skews or outliers, so then we get our normal or large sample condition. If you are working on a homework problem or on a test problem where you get to the AP Stats exam in May and a graph is provided for you, you don't have to re-sketch the graph. You would need to sketch a graph if there is no visual and you have to check this condition in this way. That's the only time you would need to sketch this out. But if it's already provided, you can just reference the dot plot that is printed there. All right. We're going to do the general and specific formulas, and then I'm going to set you guys loose to finish up the rest of this page on your own. You may work together if you would like. What is the general formula for any time we do a confidence interval? Point estimate plus or minus margin of error. Do we still use p hat for our point estimate? No, that would be for a proportion. What are we using for the point estimate now? X bar. So X bar plus or minus. How do we calculate the margin of error? We learned how to do this yesterday. T star. Yes. T star times, we won't know sigma, so we have to use S instead. We have to use the sample standard deviation divided by the square root of n. Remember, this right here is the standard error. Of X bar. All right. I'm going to give you guys, let's see how far we get in 5 minutes. All right, take 5 minutes. If you do not have a formula sheet, you can come up and borrow one from me so that you can look up your T star. You absolutely may come grab one from here. And we'll touch base again in about 5 minutes to see where you're at. Okay, degrees of freedom here. 12 degrees of freedom. It's going to be n minus 1. Since we had 13 pieces of data collected, we have 12 degrees of freedom. So then we plug our numbers in. What was our X bar again? $395.769 plus or minus, and then we need T star. What is our T star? 2.179 times what? Absolutely. 184.708 divided by the square root of 13. What did you get for just the margin of error part, the part where you had to multiply T star with the standard error? What do we get? What do we get for the margin of error? Again, I know X bar stays the same. Yes. Got 111 point, about 628. If you rounded slightly differently on the X bar and on the standard deviation, your numbers should be close to mine, but it might not be exactly the same. I used the exact numbers that we got from the applet. And so then we end up with an interval that goes from 284.141 to 507.397. Yes. Nope. I usually write it down just so that way if I do make a mistake or I got something wrong in there, I can go back and it's like, what was I using for that again? But no, you do not have to show your degrees of freedom there. You just need to know where to go and look on the table for that. All right. So far, so good? So what would a conclusion look like for this? We are 95% confident. Close. You read me my X bar as the lower bound. 284.141. That's okay.
So sorry.
That the interval from 284.141 to 507.397 minutes captures the true proportion of, or sorry, not true proportion, but true mean of what? Yep, of screen time for all AP Stats students. The CDC recommends that teens spend a maximum of 120 minutes on their phone per day. Based on the confidence interval, do we have convincing evidence that AP Stats students are having more screen time than recommended? All right, I'm getting lots of yeses. Explain. 120 is not captured in that interval. In fact, all of the numbers in the interval are above 120 minutes. So I would say yes to this. All plausible values for the true mean screen time for all AP statistics students, and I spelled statistics wrong. Statics, has most of the right letters. There we go. Statistics students contained in the interval are greater than 120 minutes. Remember, that interval is giving you all of the plausible values for the true average. So far, so good? How did you guys feel about the 4 C's on this? Feel pretty good about it? Hopefully a lot of it feels familiar from when we did this with proportions. Let's go ahead and flip the page. We've got our 4 C's written down for us. Choose, check, calculate, conclude. The specific formula is different than when we did this for proportions. Now it's x bar plus or minus t star times s divided by square root of n. What's different about the procedure this time? Again, when we did this for proportions, it was a 1 sample z interval for p. And now it's what? Yes, 1 sample t interval for mu. What is the parameter that we will be defining? Mu. We will be defining mu. All right. I'm going to give you guys 10 minutes to do the check your understanding, and then we're going to compare your answer with mine. So take 10 minutes to do that. All right, let's check yours against mine. So first we have choose. You should be choosing a 1 sample t interval for mu with a confidence level of 99%. Mu is the true mean weight of garbage for all households in the community. And then when we go to check our conditions, random, we had a random sample of 15 that was given up here. 10% condition, 15 is less than or equal to 10% of all households in the community. And once again, we had to use the graph, the dot plot, to justify normal large sample condition. The dot plot showed no strong skew or outliers. Real quick, thumbs up, thumbs down. How'd you do on this first 2 steps? Cool. All right. Let's go to the calculate step then. For calculate, we of course have point estimate plus or minus margin of error, which means x bar plus or minus t star times s divided by the square root of n. We have 14 degrees of freedom. So that gives us a t star of 2.977. We plug in our x bar, our s, and our n. Means I get 59.5 plus or minus 20.91 for an interval of 38.59 to 80.41, or if you did 38.6 to 80.4, that would be fine. And then conclusion, we are 99% confident that the interval from 38.59 to 80.41 pounds captures the true mean weight of garbage for all households in the community. Please, please, please make sure that you are putting units on that interval. We didn't need to do that for proportions because proportions are percentages, but now we have units for what this interval is talking to us about. You guys feel decently well prepared to tackle the homework? Awesome. Homework's due tomorrow. If you would like to do some additional reading to help because you get confused or flustered at different points, pages 648 to 663 in your book, 648 to 663 cover what we did yesterday and today in class.